In this video, we'll go through some examples of exercises that you may come across in ordinary classroom teaching. And so you can see my links here down the page, setting exercise for learning and assessment. And you can open this link. And then the second file here contains a set of miscellaneous examples, various questions that you may come across in worksheets or exercises or homework based on textbook materials. So here is my file. Okay. So here's a collection of questions from different topics in our curriculum. So they are all related to assessment or question or exercises, and so they're collected here for some discussion and sharing, but they are not supposed to be definitely good question or better question. It depends very much on the context, right? So they come from different situations where there are certain reasons of modifying the questions, right? But bear in mind, it doesn't mean that any one of this is definitely better in all classroom or all kind of learning situations. But the more important thing is that we want to highlight the relation between assessment, teaching, and learning through the settings of the ordinary exercises. So the first one is about polynomials and remainder theorem in higher forms of secondary schools. And so the page here is just an image of some common worksheets that you may usually come across in our textbook or in our teachers' exercises. What I want to show you is that, so although these are very common, right, so however, they may not be so useful for developing the students' understanding in the process of learning. So very often, they just illustrate the skills or techniques that they need to answer questions, right, in exercises or in examinations. And so as a comparison, I like to show you one source here and extracted from a journal paper in Singapore. Right, so this is the link to get the journal paper in 2006, Volume 7, Issue 2. So you can directly download it from the website. So that is the journal paper, and inside it there are a few sections talking about the remainder theorems and polynomials. So this is one of the questions discussed. So you can see that it starts with questions like this. So P of x is a polynomial, which is defined in this way, or you can say it's equivalent to this one. And then you're asked to answer the following questions. So what happened when P of x is divided by this polynomial or this polynomial? So you can compare with those questions that you may come across in the textbook. So this one actually is more related to the way we understand these polynomials and relation, particularly when you first explain this theorem. Probably you will use examples like this. So in the exercise, we also include this kind of question that may link or connect with the explanations we give in the classroom to further reinforce the concept behind the theorem. So it's not necessary only giving them exercise to test the students the knowledge or the skills of using the theorems. So the other questions are similar in this way. You can go through them and try to have a look and try to compare with the usual questions that we may have in our classroom. So they all may have some elements of helping the student to develop their understanding, right, while not focusing too much on the technical skills or the mechanical procedures of using the formula to do things and find answers. Another example is also similar. It's about simultaneous equation, usually learned in the junior form. And so this is another typical worksheet that you may come across. Usually we'll ask the student to try a lot of examples like this to practice solving the simultaneous equation. And each one of them can be quite complicated or difficult for some students. And during the process, of course, there can be different ways for them to make mistakes, right? But it's not that easy to focus on any particular part of the solution to help them learn better and more about the methods and skills. So in this set of examples, we can try to consider this kind of questions. For example, this one is helping the student to understand how to add two equations together, right? So we may try to see how far they really understand the process of adding the equation. So we're not focusing on the complete solutions of solving the simultaneous equation, but focusing on only part of the solution. So this is another possible way of asking. So which of the following is correct based on the two given equations? Can they make a judgment, try to decide which equation can be derived from the above equations? Another one, which is also in the same line, right? So if you're given two equations to solve, can you see which one is equivalent from one of these two equations? So it's all touched upon the same ideas, how far the students understand the individual techniques involved in solving the equations. So this is another topic about inequality. It comes from a multiple choice questions, and that looks very complicated because it makes the choices. Okay? So it gives a very complicated combination of choices for the student to do. But instead of present the question in this way, we can ask the student try to consider all these roots given. So which one are the roots and how do they solve it? So what would be the strategies or techniques to find out the roots or the possible roots? So the form, that means the way you present the question may affect how they approach or tackle the problems. Now this one is about percentage change. The original one is about the above one, starting from a monthly range of this amount increase to this amount. And the original question is the second one, what is the percentage increase of the monthly rent? Now the highlighted part are the additional elements included when we modify the questions. So why we modify the question in this way is because we can actually ask relevant questions so that the student can express some of the expressions involved in the calculations, or try to make distinction between all these expressions. That means the focus is not merely about finding a particular answer, but also try to make comparisons of different expressions as well. So that is, once again, is contributed to the process of learning. The second one below, similar in this sense, the underlying part are the additional parts, okay, after modification. The original question is finding the percentage change in his weekly income. So you may wonder whether the additional part is added in order to make the question easier. It may be, it may help the student to solve the problem by giving some hints, but at the same time, it also comes from an observation that some students can answer part B without setting any unknown x in the calculation or skipping this part. For example, they can just simply assume that the starting hourly wage is $100. Then they can still answer part B successfully. So the part A, that means may require them to work in a particular way or to make use of the unknowns in order to express the answer in a formal way. Interestingly, in a trial with some Form 3 students, some who usually can work out the answer B more directly and quickly turn out to have difficulties in understanding part A, or failing to actually answer part A even they can answer part B. So it reflects to what extent the student really understand the method of calculations behind it, if you are not allowing them to express more of these ideas. So another question is also about percentage change. So these expressions sometimes can be a summary given in the textbook to remind them what should be the formula of finding the percentage increase or decrease. But in this question, we set it up like this so that students have to make a choice to try to analyze carefully what these expressions really mean. So we are not asking them to remember a particular formula, but we're asking them to actually make sense of the formula. or try to compare with similar or sometimes maybe equivalent expressions, even though some may be more intuitive or more familiar to them. So we turn to another topic. This one is about mensurations. It's about finding volume or surface areas of a pyramid. So the original question is part C. The one highlighted in A and B are the additional parts after modifications. So the reasons for adding part A and B is to emphasize the importance of understanding the properties of the geometric objects. So even though some students may go directly to part C, or most of the textbook will focus only on part C, okay, and talking about how to do the calculation. In fact, part A and B are the essential elements of understanding the calculations. So you can imagine if the student cannot tell which of these angles is a right angle, or if they cannot tell which of these triangles are isosceles triangles, that means if they cannot distinguish which triangles have two sides equal in this figure, then their understanding of part C should be problematic. That means they maybe just follow blindly the usual procedures of finding the surface area, but without totally understanding the actual geometric properties that should be involved. So that means these questions, once again, is part of the process of helping the student to learn more, or also for the teachers to understand how far the students can really grasp the ideas or the concept behind the methods and procedures. So the next one is about trigonometry. Here, the question is given here above originally without a diagram. But you can also consider to what way you can include the diagram, or what details in the diagram will provide, and what will be the implication. Right? It's not simply making the question simpler, right? But we may have help the student to express what they know about the figure. Depends on how far you think your student understand the situation. So in this figure, what we suggest is just put down roughly the position of A, B, and C, but the actual angles are not included in the diagram. So the students may have to fill it up and try to input or try to tell each other where are the angles mentioned in the question. This can be part of the discussion among themselves with each other before completely solving the problems. This is another question in geometry, and it's also different from the usual textbook exercise, which focus on the standard techniques of finding unknown angles, or sometimes emphasizing on formal proof. Right? So this is about reasoning, about the angle properties and the lines, relations between the lines. But on the other hand, it is not totally relying on writing or formal proof. It's more about observing or analyzing the diagram more carefully and making judgment in a sensible way. So, so it can be also another kind of question that you can consider, particularly if you're interested in the student's learning process. Another question in geometry, which it is expressed in the form of multiple choice question, but it can be used or it can be presented in many different ways. The main point is to ask the student to judge each of these statements, to what extent they agree with them based on this figure and the given conditions. Right? So once again, it is another kind of questions that focusing on the reasoning, but not necessarily relying on complete or formal proof. These questions is more about advanced topics in calculus. Even in sometimes advanced topic, we can also include this kind of conceptual questions to assess the students' understanding and further develop their understanding as well, without relying too much on the technical details. Just like this one is about reading these symbols carefully and also reading the graph in a careful way. To what extent they can understand the sign of these values in this figure. So is f of r positive or negative? Is this one positive or negative? Depends on h, the sign of h, so they can try to put it down, and then you can see how far they understand the meaning of these expressions. Similarly, this is also another one to test their understandings of the expressions and the reading of the graph, but not necessarily relying on too much technical details. So it is another question also in calculus in a similar manner. Now finally, a set of questions is suggested here based on one textbook problem, which you can easily find sometime in the textbook, and some teachers may even choose it to include it in their homework as a kind of challenging question for some what they consider as faster students, right? But actually, this question may not be so suitable for the majority of the students if you are expecting them to learn together. There's some fundamental concept involved in these sections. So the concept is about the slope, the slope between 2 points, and in what way we can ask the student to learn more based on the exercise that they are doing. So here is one way of modifying the question. So you can ask the student to suggest any point B, so which can make a line of slope 1/2 with the point A. And you can further suggest the student to express the answer in different ways. It can lead to a different kind of sharing and discussion. So it's not about reaching a particular final answer and see whether they are right or wrong, but it can be a means for the student to explore and discuss with each other while working on some reasonable questions, right? That means working on some manageable question, not too difficult or not too simple. And so this is another form of presenting the questions. So can they suggest different point B? That means more than 1 point. So this becomes a more open question. The students can continue to do more if they feel comfortable. On the other hand, for those who may have difficulty, can focus on a more simple beginning first, and they can even put down a little bit more details about the horizontal change and vertical change, which can be positives or negative. Or you can encourage to ask them to suggest some examples in a particular manner. For example, can you suggest a point so that horizontal change is negative? Then what would be the result? In this way, the question is further extended and can give different challenge to different kind of students, depends on how far they can work on this question. So without a very rigid framework. And at the same time, there can be a lot of things that they can learn from the results here combined together after trying the question. And more important is that they can also use a square grid, okay, and then try to express the answer on a square grid and even make use of it to make observations, or make use of the grid to make sense of the answers and the calculations. So similarly, we can work on distance instead of slope. Right? They can use a similar format to initiate certain kind of questions. And then, if you can work on slope and distance, we can even combine them together in one question. Right? For example, we can ask the student to suggest points that keep the distance change, but see how the slopes may vary. Or the other way around, we can ask the student to give points so that the slope maintains the same, but the distance varies. Right? So in this way, they can compare or contrast the two formulas, distance and slope, in one particular exercise. So we can add to the further understanding or advanced understandings of this concept. So it's not merely giving some challenge for certain and faster students only. So this is a set of examples I'd like to share with you. Right? So you can look for more examples, maybe in other files I provided in my notes homepage.